Hi! This video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video.
Hello, coders. In today's step 23, we're going to go back to the high score table again, but we're going to do names this time. Now, because the names and the score, last time we did the scores, and I had a very short chat with Georg, and he said, I already knew how to do high score tables because I did them in C++ or some other higher language. So I knew what to do, and he basically transferred that knowledge to assembly. Now, it looks a bit more archaic, perhaps, but it's good that this time we talk about adding names to the table, because the mechanism is the same, and we can sort of revisit the same technique, but now with names. We're going to be entering names, we're going to be checking the keyboard and that kind of stuff. So I am going to draw some things. So I have my pad connected, which means I don't have a joystick connected. So I first want to take you to what things look like, and I'm going to reprogram the keyboard to do this. Settings, joystick settings, and we're going to set it to key set A, and we're going to configure key set A, and south is that, west is that, east is that, north is that, fire button is that, and we say okay. Okay, now let's have a look. This is the high score table as we know it. So we have Supernatural and the score. Now this is also the this is also the storage for this information. There's no other place in memory where this is stored. So we're manipulating this, and they look like a table here, but they are actually a consecutive number of bytes in memory, which we'll go into in a minute. So first, I'm gonna have to try and beat the lowest score at least to get into the high score table. So let's try and do that. Shouldn't be that hard. I shoot this bat a couple of times. 40. Oh, even get some. Oh, we're already over the score. Let's try and get a little bit higher. 1, 2, 3. Let's not die. I think we need to get over 300 now, which this zombie is going to give us a hard time. It's funny that we're actually playing the game. So that's 270 already. Now we wait for the zombie here to keep moving. Right, we're reloading. It's good to see that we're not reloading if our bullets are full. So fire 3 of them. Another one. They're 380. We should be fine now. We'll get ourselves killed here a couple of times. Press fire to restart. And another one. And this is our last life. Okay. Now we made the high score table. As we can see, there's still a few wrongs here, but we can see here that we have the high score table, and there's one place that is open. This is where we can enter a name using the keyboard. So we're going to type Highlander. I can type a space as well. I can hit delete and it'll go back, and of course it won't go beyond the first position, so we'll type Highlander, and we can keep typing, but at the end we just stop. And if I press enter, it's finished and everything looks the way it should. Now let's have a look at the code that does that. The entering of the name is actually quite easy, but the making a place and moving everything down, what you see, and this goes for any high score table, as soon as you have a limited number of spaces in your high score table, we have 8. And as soon as you reach a score that is in any place on the high score table, the lowest one always drops off. So that's good to that makes sense, right? The lowest always vanishes. So we've already in step 22 we did the score. Now we're going to look at this. Again, the representation here is a table, but we also have to look at it as one long string. So let's look at the data. Nothing's changed here, by the way, but this is what it looks like. Now, again, it looks like a table here, but these bytes, this 0 just comes right after this minus sign. We're looking at the names this time, so this S right here comes right after this minus sign. This just means for the routine that prints this stuff on the table on the screen to go to the next line. Now the word supernatural is 12 bytes long, so that's 0 to 11, and then number 12 is that. So the length of a high score entry table for the name is 12. We're not counting this one. There's a constant that says that. We're going straight to the part, and I know the line number that I want to look at, where the new code has been added to move the names down. Now, let's have a look very shortly at the way this is supposed to work. You're looking at Sketchpad. I'm going to try and draw some things, but it's not going to be straight and neat. Let me check if this is happening. Oh, there we go again. There we go. Right. Now, this is basically what we saw. We saw a table, and it has 1, 2, 3, 4, 5, 6, 7, 8 entries, 0 to 7, and each entry is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, with a minus at the end, and this is 0 to 11, and then that's 12. And this is the way that it's set up, and the way that it works. Let's have a look at a different representation of this, because this is one high score entry, with all the letters and with the hyphen at the end, and then the next one comes. And this is the next name, supernatural, or whatever name we entered, and the hyphen, and so on, and so on. There's 8 of these. So that's a good way of looking at it, because this is the way it works. We have one value that points to the place where our high score is supposed to go. And this is parameter 1. Also, there is, and this parameter 1 just holds the number, a number between 0 and 7. Then there's another pointer that just points at the last one, parameter 2. And then we have the Y register, and that points at this entry, but it points at the start of this entry. And it's good to realize that this Y value doesn't hold a number from 0 to 7, but it holds actually an index into this table. So in that sense, it's better to look at this information as the string, because where parameter 1 and 2 hold values of, this would match this entry, and this 1 would match this entry. But y, if we go to the last 2 entries, one, it's a hyphen and a hyphen, y will point to the first byte of the second to last entry. So it's whatever number of bytes. This is like 13 bytes times the length of the number of the entire number of entries minus 2, right? Which is, let's say it's 63. But that's an index into the high score table. Now, the trick is to move all of these. We start at the bottom. This one, this entry is lost, and then we basically copy all the bytes from here to here. That right? So that we've copied this entry to the last one, and we repeat that process. So we copy that one to that one to there, that one to there, until parameter 1 and parameter 2 are the same. Because at that moment we will have shifted all of these entries, because we want our entry to go in this block. So we have to move all of them down, starting from the bottom. So this one goes away. It goes in a little bin. We don't need that anymore. And this entry goes one down, this entry goes one down, this entry goes one down, and this entry goes one down. So until parameter 1 and parameter 2 are equal, we shift everything down. And that's the moment where we can start doing our magic. Now let's have a look at what that looks like in code. I hope that kind of made sense. Remember, parameter 1 and 2, they have the value, because this code that we're looking at actually comes in right after we've set the score, the number part of our high score. This is where you compare whether parameters 1 and 2 are equal. If so, then we jump to set new name, which is where the name entry comes in, which we'll look at in a minute. And if not, then we have to do this. We're going to start copying names. So remember that y was pointing at the second to last. That is actually what happens here. We should go up a little bit, because this is where the move names down code starts. So first we set parameter 2, which is the high score entry count, which is 8. We have 8 entries, minus 1 because we count from 0, so that is 7. So parameter 2 is 7, which is basically pointing at the last entry. Then y is the high score entry name size, which is 12, plus 1 for the hyphen, times the high score entry count, which was 8. We have 8 entries, minus 1 because we are counting from 0, minus another 1 because we want the second to last one, because we want to start copying names down. Right, so this is parameter 1 set, and this is y parameter 2 set, and y, and parameter 1 was still set to the point where our new entry should be. So when they are the same, we can set the new name. If not, then we start copying stuff. So we take the first byte of the entry that is the second to last, and we copy it where? To the last one. So we copy that to high score name, which is start of the table, plus high score name size plus 1 plus and indexed by y. So we copy it to the row below it. Then we increase y, which is of course our pointer to the next byte, and we increase x because we want to know when to stop. We compare x to the size of the high score name, which is 12. We're not actually copying the hyphen here because as soon as we hit 12, we stop. So we missed the one hyphen, but that's okay because the hyphen is the same for all of the names. We don't have to copy that. So branch not equal. So we compare x to the size. If it's not 0, BNE means branch not equal to 0. So we test the 0 flag, and we can copy the next name character. So this basically copies, on the first run, it copies the second to last entry to the last entry. Now we move the y, which is now at the end of the last one. We move it to y is pointing to the end of the second to last one. We move it to A. We set the carry because we're going to subtract, and we're going to subtract the high score name size plus another high score name size plus 1. The 1 is for the hyphen, and we transfer that to y. Now this means that y is going to be pointing at the start of the previous entry. We decrease parameter 2, which no longer points to the last entry, but to the second to last, and we jump back to copy names. So this process basically copies names one line down and moves the pointer up until parameter 1 and 2 are the same, because that's where the routine starts. So what happens when we do set new name? Set new name, we have we move y to parameter 1 because I think we want to save that. Then we're gonna set a to 0. We're gonna compare y to 0. Now we load y with the value of parameter 1, which is the number of the entry. Now let's see. We compare y to 0. If it's not 0, then name offset found. Otherwise, oh, wait a minute. Clear the carry, and we add the high score name size, and then okay. We go and decrease y. Y was the value. Parameter 1 was pointing to wherever our name was going to. Oh, okay. We're going to calculate a new position for y. Y is going to point at the first character of the name that we're going, that we're going to be typing a new name into, and we do that by starting at the place where we're supposed to be. Why do we do that? We compare y to 0, and we do that a number of times. So we right. Oh, of course. Parameter 1 is the number, and basically we're multiplying the number times the high score name size, so that y is pointing at the right thing. Okay, that's easy, right? So we put that value in y. Y decreases at every iteration, and at every iteration we add high score name size plus 1 to the accumulator. And we do that until y is 0. And if that is the case, then the accumulator then has the value that we want. We jump to name offset found, and we transfer a to y. So y again is pointing at the first character that we need. Now we're going to clear the old name. we store y in parameter 3 this time, so should have a little bit of an overview. Let's do the overview first, because now we're going to look at. We're gonna clear this out because we've done this. Now we're looking at the name. Remember, this is one of the 1, 2, 3, 4, 6, 7, 8, 9, 10, 12, and this is the hyphen. So 0 to 11. We've got y pointing there. And let's see if we can, because we're storing y in parameter 3 here, and we're restoring it there. So basically what's happening here, we're loading a space into the accumulator and storing that in this high score table indexed by y. We increase y and x until x hits the name size. If we're not there yet, we clear the next character. So basically we're filling that space with spaces. And when we're done, we reset y to the beginning of the string. Okay. Next, we're going to enter a new name. So we set x to 0, and now x goes to parameter 3. You see how parameters are being used. Parameter 3 was y here. Now parameter 3 is x. We have to keep track of that. So we're gonna draw that in our little. Where's my mouse? There. Draw that in our little thing. X is also 0, so we're going to just say x points there, and x was parameter 3. We're going to just do it like that, parameter 3. Get that out of the way. And we call show character. Now, show character or show care, all this does is it, well, we can have a look at it because it's a jump. So let's just go to the declaration, which is just a little bit farther down. Oh, that wasn't, I'm scrolling up now. No, well, okay. And x and y are stored in parameter 3 and 4. 6 goes into parameter 1, 10 goes into parameter 2. Those are coordinates. Then we get the start of the high score table and we do display text, and then we restore x and y from parameters 3 and 4, and we jump to get next character. So this basically just paints the entire high score table on the screen. Boom. That's what show character does. Now we go back to, then it jumps to go, get next character. So we go there, and that was just below where we just jumped from. So we just do a little. We don't use a subroutine like a JSR. We just do a jump and then a jump back, because apparently this is how it works. Now we store y in parameter 4. So I want to just make a little note of that so that we know that. This is parameter 4. Right? And lo and behold, we have one of the kernel routines. This is why we want the kernel in memory. This is right at the beginning. I think it was in the first or in the second episode. We chose the memory map, and we didn't choose to have 64K of RAM, but we chose to keep the kernel present, which is for this reason, so that we can tell the kernel, get us a character. And that's what it does. It just reads a character off the keyboard. If the return value, the return value comes in the accumulator, if it equals 0, then get next character. So basically what this does is just loops very quickly until we get a character. Now, when we get a character, we can just start comparing and seeing what it is. So we compare it to 13. 13 is the enter key or the return key. If that happens, then enter was pressed. We'll have a look at what that does in a minute. I just want to see what happens because enter pressed is the end of the show, right? Delete was pressed because we want a delete function, of course. We compared to 20. Apparently, 20 is delete. If it's not equal, see what happens here? If it's equal, then we know that enter was pressed. If it was not delete, then it was a normal character, and we go to not del, and this is what happens when you press delete. Now, if you look at this code, this may be a little bit confusing, but we get y and x from parameters 3 and 4. Now, we have to know and remember that y is our index into the entire high score table, so that is any number from 0 to 60, 70, whatever, and x counts from 0. So that's the counter from within the string. This says that if x is 0, then you cannot then delete does nothing, right? So we just go to get next character, which goes back to that read loop. If x wasn't 0, then we have to decrease parameter 3, which is basically a copy of x. We decrease y, which is a pointer in the entire table, and we decrease x, which is a pointer within the same string. Then we put a space in that place, and we show the entire table. So this means that every time we press delete, a space is placed on the character that we've just deleted, and the entire table is shown. Not just our string, the entire table is shown. But it happens so quick that you don't see that. Now, what happens when we didn't press delete, so we pressed some other key? Then, again, we get y from parameter 4, and we check whether or not the key that was pressed is within like a readable character. Now, 32 is space and is also the start of the readable characters. This does a branch carry clear. What happens in a compare is that 32 is subtracted from the accumulator holding the key that we've just pressed. In subtraction, whenever after subtraction the carry is cleared, that means that the carry was used and the value that was in the accumulator must have been smaller than 32. So branch carry clear, hey, it was smaller than space, so we just get the next character because it was a character that we cannot print, right? 9-6, off the top of my head, I don't know which character that is, but it's a typable character. If after subtraction the carry is still set, that means that subtraction was fine and the value that was in there must have been higher, and we go to the next get the next character. Otherwise, it must have been in between these values. Again, we get x from parameter 3. Apparently, we trust parameters 3 and 4 above everything for the value. We compare it to the name size. Again, we do the carry check. Let's see what happens. Get next character. Max length reached. Branch carry set. Otherwise, we save the text. Increase. Oh, okay. We don't increase the X and Y pointers when we're already at the end. So we just go to get next character. As you saw, we can keep typing, but nothing really happens. Otherwise, we advance to the next character. We store whatever we had in the location that we're pointing at. We increase Y, we increase X, and then a show character comes. So we save X and Y, and then we do the entire printing of the table again. And we jump back to the get next character. Now, we still have to look at what happens when, because we saw delete, but what happens when enter is pressed? Well, that no doubt is here. Whenever you press enter, okay. Whenever you press enter, this happens. We load the accumulator with a space. X and Y are loaded from parameters 3 and 4. Are we already at the end? Then we're filled up. Filled up means just jump to title screen. Otherwise, we store the space in the location that we're pointing at, increase Y, increase X, and jump to fill caret. So wherever we stop, we press enter just to make sure all of the rest of the characters are filled in with blanks. And it's done. So I hope, together with all my lovely drawings, I didn't pull this up anymore. I didn't feel like it was necessary. But as you can see, these X and Y pointers, they keep moving up and down on delete and typing. And their values are constantly being pulled from parameters 3 and 4 just as a backup, because we know that parameters 3 and 4 are being used for, or X and Y being used for other things. So we move up. When we get here, we don't advance. When we do delete and we get here, we don't advance that way. We check for every character, is it a printable, yes or no? If we press enter anywhere, then anything afterwards is filled with spaces, which is a 32, or a 20 for those who think in hex, which is a space. And that's it. That's it for the name stuff. Because we've got a name in there, and we don't have to do anything else, because the way it's shown in that piece of memory, that is it. There is nothing else. Now, in any higher level language, I would have used arrays, of course, to store the high score table, and I would probably just sort the arrays, or just it's much easier if you have something, a language that is type aware and that can have arrays. Now, you could build routines that mimic arrays in assembly, but the amount of code that would require is much more than the way it's been done here. And that is assembly. That is low-level byte wrangling, basically. That's the way it works. There is some room for text here. I think this was just part of a trial, and Georg forgot to delete it. This is not used. We should okay, unused label text. See, that's what happens. That is also it for this episode. There's one thing that I've been burning to say, is that in the last episode, Georg decided to use a way of addressing the VIC by using the VIC's base address in decimal and then adding decimals, and it's a different method, but it doesn't have my preference. And lo and behold, I'm very happy to see that in the next episode, this one, he's returned all of the original labels, and maybe he was, at the time he was writing this code, he didn't have this little pop-up yet. Maybe he thought, what if I just make it so that every time I hover over a value, we just get the pop-up with the correct values, and I'm saved. I'm betting, and I hope that Georg is watching this, I'm betting that is what he did. And if he doesn't watch this video, I'm going to ask him on the Cytronic forums, and we'll see the answer there. So, and put myself back in the picture there. Thanks for watching again. It's occurred to me that, this is something that I've wanted to say as well. If you think that the secret to games programming is in the difficulty of assembly language, and that by mastering assembly language, you can do games programming, That's not true, because learning assembly language isn't hard. What is, or what may be hard, is learning the game programming techniques, and that's exactly what I'm doing with this video series. I've now explained how to do a high score table. This is valuable stuff. You can do different kinds of high score tables, and this may not be, as Georg said it, the cleanest or the best code, but it does the job. So we've been given a little peek into how it can be done, and we can build from there. So each video is basically one lesson in games programming technique, which may be very basic, but it works and it's very useful. So thanks for watching, and I'll see you in the next step. Bye-bye.